Okay, this is, in my opinion, this is a really big opportunity to kind of like really pad your grade because you got 2 tests over not a lot of material here, right? I mean, this is not a huge unit. You get technology on a lot of this. Half of this test 5, is broken into test 4 and test 5. Test 5 is really mostly about just being able to use the technology. Okay, so what do we got going here? Linear regression examples. I want to look at those real quick. Does that seem really dim? Like dimmer than it's been? Oh, let's see here. I think they're. Yeah, I can do that. That's better. There we go. Okay, so linear regression examples. How many people, raise your hand if you need a little practice on linear regression? Anybody having struggling with that at all? Okay. Okay, that's not a good sign.
Oh yeah, I got a 75 on one of the and I didn't even try to redo it. It was too hard.
It's
wrong and you have to redo the entire problem.
okay, so I picked problems on the test that are going to not take you long to do because you can cut and paste. Yeah.
You have to use R and R squared. Okay, I'm just curious, what does R mean and what does R squared mean?
Okay.
R squared is
Okay, let's answer that. What's R versus R squared? Because that's going to come up when we do regression. What do we call R? No. R is the correlation coefficient, right? We don't do a ton with that right now, but really what that tells us, if it's positive, it means that you're going to get a regression line with a positive slope. If it's negative, you get a regression line with a negative slope. Okay. R squared can never be negative. R squared is what we call the coefficient of determination. There's a question on the test where you have to know that. And when you go through the review, you'll see that. This is the one that we can convert into a percentage, right? So this is the one, like if R squared is equal to 0.85, let's just say, then that means 85% of the variation in the output variable is explained by variation in the input variable, right? So it's telling us kind of essentially how good a fit is this, like an 85% fit to the model, okay? And we'll look at a problem like that today. All right, so let's try one of these together. This is the stuff where you're going to be using Desmos graphing. Okay, so what do you do on this? We're supposed to draw a scatter diagram, determine the regression line, and then graph the linear regression line on the scatter diagram. So this is all stuff that's going to be completely done for you with technology. I'm just going to click on that little copy icon, copy to clipboard, and then you can't see that right now, but if I make this smaller, you can maybe. Let's try that again. There you go. And so it highlights everything, all the data. You have to hit Control. You got to actually copy it. So you hit Control C. And then in Desmos graphing, you're just going to paste all that stuff. Okay, look what it does. And then, so not only does it do that, if you click the plus, the zoom fit, it even zooms in on the data. This makes it really simple to pick which is the correct graph because it's that graph, right? Here, let me just take a picture of that. So you got to pick which one of these is the right one. You can kind of see that's it right there, isn't it? Isn't that the one that matches? Like if there's that one. Isn't that what matches that?
Pretty darn close.
Right? I mean, of all the choices, that's going to be the obvious choice. So, I mean, really, you're just using the technology to create a scatter plot. And this just, you're verifying that you can make a scatter plot. So that's no big deal. Okay, part two. Part two, and then, okay, it asks you, this appears to be what kind of a relationship? Which one? Linear negative, right? And that was the one, okay? We want to write the regression line. Okay, well, create the regression line. I don't really need the graph here for this stuff. Okay, so I do y1 tilde, right? That tells me that's Desmos's way of building a regressional model. Y1 tilde m x1 plus b. Okay. No, you just got to know how to do it. You got to know how to use technology. So this gives you everything you need to know, right? Okay. It tells you the values of M and B. It's going to ask you to round those. You got to look very carefully. It's up to you to look to see how many decimal places you're rounding it to, right? You got to look at the little blue writing under the answer box. And it always tells you how they expect, like how the answer should be formatted. So there it is. In later questions, they're going to ask you about R squared. Well, there it is. There's R squared, right? It gives you all that information. Yes. R squared is the percentage. That's the coefficient of determination. R is the correlation coefficient. We're not, I mean, in future years, you'll do more with that, but not so much this year, okay? Well, the R squared is the one that's telling you the percentage fit, okay? Right, and that's the one that's always positive, so it makes sense, okay? All right, so then we would just take these numbers right here. Here, I'll do this, let's see. Okay, so then we would go into our regression model here, and there it is, right? We're just plugging in that value of M and that value of B into the regression model, rounding to 3 decimal places. So that means that, what's that telling us then? So the slope rounded to 3 decimal places is negative 0. What? 695. There it is. Okay, the y-intercept rounded to 3 decimal places is 6.531. Exactly. Okay. And then we want to choose the correct graph below of the regression line graphed over the top of the scatter plot. So all you'd have to do there in Desmos graphing is we want to graph, well, there it is, right there, right? That's it. Okay. And so we would just match that picture to the correct graph, which is going to be, you tell me, which one, A, B, C, or D? D. Yep. Okay. And that's it. Okay. Next one. Next one is all they're wanting here. Okay, this is same kind of stuff. They want the regression equation, but they want a prediction as well. Okay, no big deal. So we're going to do the same stuff. We're going to go up here. We're going to copy to clipboard. I'm going to Control C, copy it. I'm going to go into Desmos. I'm going to paste. There's my scatter plot, right? Okay, I can kind of, I can make that picture look however I want to. I can zoom out a little bit if I need to, but there it is. I'm going to go down and create the regression equation same way, y1 tilde mx1 plus b. There it is, right? There's all my stuff. Okay, so that's all we need for the first part. But for the second part, they want something more. They want to know predict the well-being index, which is the output, right? That makes sense? Predict the output based on an input of 30. Okay? So do you remember how I would do that with technology? Into what? Okay, but I don't want to make it y because I want to be able to input values. F of x. Good. I want to write it as a function. So f of x equals mx plus b. And I don't have to type the values because it's going to keep all those decimal places, and probably it's even got more decimal places than that behind the scenes. Right? Desmos is calculating and keeping those values, storing those values. So it already knows what m and b are, so I can just write those in as mx plus b. Now all I have to do is go down to the next row and evaluate that function at 30, and there's my answer. Okay? So let's okay, so then what's that going to give me for my answer? So I'm going to round to 3 decimal places, so that's negative 0.083. And then my y-intercept is 69.095. Uh-oh, that's going to be a problem. Negative, okay. And then what's my predicted output? 66.600, yeah. Okay, make sense? Check answer, got it. Okay, give me thumbs. Okay, all right, next. What is this? R squared is what? Coefficient of determination, freebie. Okay. Okay, which one of these is going to be the R squared of 0.62? I got 0.62, 1, and 0.9. Which is the top one going to be? 0.62. So that's going to be A, right? Or that's going to be, yeah, 1. Okay. Second one, 1 is going to be which one? 3. Good, which means that one is 2. Easy. Okay. Okay, this is the one about interpreting the variation. So we would do the same kind of thing on this guy. I'm going to copy all the data. So Control C. Paste. Go down, make my regression equation. And now you guys tell me how to use that information. Oh, there it is. Hold it. Where is my? Yeah, but I kind of messed that up. Where's my? I don't think I copied. There we go. I do this again. Okay, there we go. So the R squared is as a percent is what? And they want to round to 1 decimal place. $91.0, right? Okay. Everybody get that? Questions? Okay, so now how about this? Interpret the coefficient of determination. What's that telling me? 91.0% of the variation in what is explained?
Let's just put height and see what happens.
It's explaining, it's saying that 91% of the variation in the output variable is explained by the relationship. So what's that going to be? Head circumference. There you go. Okay?
Is that always true?
Yep. Okay, I don't think we need to do any of those. We're good on all those. Okay, we did that. Okay, let's look at just a couple quick examples of these. I know these are so simple, but I just want to make sure everybody's okay with this. So on these, remember, what's your strategy when you're solving any kind of math stuff? First, you have to define the variables. So read through this real quick and tell me what's x. First number, what's y? Second number, okay? So now we've got to come up with two equations. Where's the first equation coming from? Okay, good. The first spot, and then what's that going to look like? X is, just looks like that, doesn't it? Right? First, one number is X, is means equal, 4 more than the second is just Y plus 4. How about this one then?
Y equals 4x minus 6.
So 4 times the first, what's that? 4x equals 6y minus 12. There you go. Just like that, right? Okay, give me thumbs. Make sense? Okay, once I've got both of those, all I've got to do now is technology, right? I have technology on this test. So how would I easily solve that system?
Put it in a
Graph them. I don't have to solve for y. I just enter the equations just like they are in Desmos graphing. Find the intersection, done. Okay, how about that one? So first of all, what are the variables? Read through it real quick. And look for the question. What's it? Number of tickets of each type, right? So we've got $25 tickets and $40 tickets. Okay? Where's the first equation coming from? There's some kind of implied information here. Like, what's an important word in this? Okay, good, because we have a sellout performance, so all the seats are being sold. There's 6,000 seats. There's our x plus y equals equation we always try to look for. It won't always be there, but usually it is in the systems equation, right? So this is the one that's just going to give us x plus y equals 6,000, right? Now, what's the other stuff?
25x plus 40y equals 181,000.
There you go, right? The total revenue, and that's going to come from the $25 ticket sales plus the $40 ticket sales is the total ticket sales. And again, all I'd have to do, what are my options here? I mean, I could either graph this, which is fine. That's a pretty big number. So the graph might be a little bit inconvenient. It's fine. I could also just throw that into a 2x3 matrix, right? Because it's already in standard form. Okay. All right, last thing, I'm going to let you work. How do we interpret this? This is from the first one, the first test, test 4. This is all that's given to you. You have to just interpret the answer. Okay, how come it's no solution? There you go. Good. You just look at the bottom row, and that's telling you that this one is no solution. Now, what if those were all zeros in the bottom? Infinitely many solutions. Yeah. Okay. Easy. Right. Okay. On the test, though, honestly, I think you'll see it on the review, but I don't even think I gave you one like this. I think I just kind of simplified it on the test, so you're either just choosing are there infinitely many or no solutions. You don't even have to specify the constraints. Okay? Okay? I mean, seriously, this is not bad, right? I mean, this should be pretty easy. Okay, get to work. Go.